And now we are to the subject of in-service, because statistics is used a lot, not just in engineering, in manufacturing, but also in the operation of industrial product. One example that is probably interesting is related to the wind twin, is how you could look at the distribution of the wind speed. We have from one of our contributor from the Scilab community, we have one example on the wind speed analysis that was provided by someone in Vienna, in Austria, and so he's doing a whole study on this subject of wind speed to look at the performance of wind turbine. That's a very interesting small article. So if you want to have a look at it, I can copy it over here for when you will be bored in the afternoon. And going back to the presentation, another, so if you look at a helicopter in itself, this might be close to what you think about in terms of a wind turbine, but just upside down. So if you look at the helicopter in operation, obviously they are facing some critical performances issue. There was one crash in, I think, 2016 of a Airbus helicopter. And so tomorrow we'll be meeting the chairman of Airbus, and he had some concern about the way to predict and follow up on failures that might happen in the helicopter powertrain. In the powertrain, one of the very sensitive aspects is a gearbox. So here, what appeared in 2016 in Norwegian and what caused the crash of an airplane was analyzed. You can find it on the internet. There's a very interesting video displaying the overall analysis that was performed post-mortem, I would say. It's yeah, so to say. And they were looking at the different aspects and factors that were causing the failure. So some of the non-detected aspects during inspection, some fatigue parameters, contact pressure. This is very much in the design, and they were not taking into account the variation of one supplier with regard to the other. So one supplier of the bearing was having concretely in the bearings of the gearbox different contact pressures than the other one, and they were not able to detect that between the design and the manufacturing. That's a very big issue that is faced by a lot of industrial company. And afterwards, well, during the maintenance, contamination and external damage were not not spotted at the right moment. So here you go, a fracture, and we love that kind of story in ESI where there's a fracture that is causing rupture. Another, well, maybe a bit more happy subject. We go back to the US and we look at the number of cars that has been sold in 1993. And so 93 cars, different type of cars. So for some of you who are, well, most of you probably love automotive. So here you have lots of very nice model of Cadillac, Chevrolet, Buick, BM, Audi, and so on. So you can look at this sample. Those are some data that you can post-process in Scilab. You can look at this example on our website also. I can show you so here in tutorial, you have all sorts of tutorials on different subjects, so machine learning, statistics. If you go and look at those famous data sets, here you have a sample from those data sets that you can download directly. You have a way of accessing those data sets very easily. Here's a tree view of what's contained in the data set with the different types of data. If it's a string, if it's a constant variable. So afterwards you can import that. So very easily read and write CSV files so that afterwards you'll be able to post-process those. Here we can represent the distribution, for instance, of the prices of the models. We can also look at different categories. So what's very interesting here, either through small camembert, I can say like this, a pie chart, or with bar charts like this, you can look at categorization. So categories that are not necessarily so continuous data, but you can look at, I have vans, sporty, small, mid-size, large, compact cars. So there's a very easy way to represent and analyze those things. And so you can look at categories like this. Here again, it's covered in this tutorial. Yeah, I can show it to you here. You have a very simple function in Scilab in order to take this data set, and with the function tabule, well, you can turn into categories. Another very good subject for statistics, I would say, it's regarding the what I call the wealth of nations. It's data set from the UN, from the United Nations. And well, some of those data you can look at, you can sort them out, because what's very important sometimes when you're looking at some statistical data is to be able to look at it in different ways and just represent, for instance, the richest, the poorest, and so on. You can look at the 10 richest country. You can look at afterwards the Pareto front, how it's cumulatively adding up to the 10 richest country being holding 27% of the wealth of the world, such things like this. So those are some representation of some statistical data. We'll go back to a very more lightest subject. This is on how to represent the winners of eating contest for hot dogs and buns. So very relevant also, maybe not so much to our strategy within ESI, but still it's or maybe we will reposition it. So hot dogs and buns, you can download and look at the data on Wikipedia. Those are the data, and this is a webpage where you can find the winners of the contest. And USA is the winner in 2019, and you can look at the different winners. So there were some Japanese before, but now US is the best. So in terms of eating hot dogs, those data, what's quite interesting is that those are HTML data, and you can browse those data with some functions within Scilab. You have so those are XML data basically. So HTML data can be browsed through this function XML read, and you can go and fetch with a very easy function XML XPath. You can look at everything that is a TD. So TD here, it's a line in this table. So you can look at them and just grab this one. So this is a way to make some web scraping. So you can get those data, those data sets a bit everywhere on the web.